Another classic example of circular motion, we've got a rotor ride at a carnival. That's one of those things where you stand inside of it and it spins around and then the floor drops and you're stuck to the wall. If the ride itself has a radius of 5 meters and the rotation is a half a revolution per second, when the floor drops out, what is the minimum coefficient of friction that we need in order to have people not slip down the wall? So here's what we're going to do. It says here, draw a free body diagram for the person. I'm going to start out with the ride. There's the ride. We've got this person on the wall and this thing spinning around. And keep in mind, we've got a force pointed towards the center here. That force is my net force. So that net force is the sum of the forces. Which is going to be my centripetal force. We're going to go ahead and draw a diagram for the person himself. Here's the person. I've got a wall right next to him. The floor is way down here. So what I've got is I've got weight downward. I've got friction working upward. That's what keeps him from sliding down the wall. And then the normal force, because he's along a surface, 90 degrees to the surface, we've got that normal force. Keep in mind, force of friction and force of weight are going to be the same. This is going to be for... Oh, we aren't given a mass. You know, we can just make up a mass. Let's go ahead and say this is a 50 kilogram person. You know, let's do this. mg, and then this is going to be mg because they're the same. So what we're going to find out is the mass drops out. Let's see where that happens. We'll do it with now let's just use numbers. The heck with it. It'll be easier. Let's call it a 100 kilogram person. Alright, so that means that this is going to be 9.8 times 100, which is going to be 980 newtons. This is going to be 980 newtons. Keep in mind, we want to find the coefficient of friction, and the coefficient of friction is force of friction over force of normal. Well, we're halfway home because we've got the coefficient of, or excuse me, the frictional force. That's going to be 980 newtons. All we have to do is find this normal force. Well, the normal force is pointed towards the center, right? Pointed towards the center, just like that net force, which is the centripetal force. So really, that's what we're trying to find. That's the normal force. Well, sum of the forces is also equal to MA. And so the normal force is going to be equal to mass, 100 kilograms, times the acceleration. Well, we need to find that circular or centripetal acceleration. I've got several equations I can use. I can go with A is equal to V squared over R. So that means I need to find the velocity. I wonder if I can do that. That velocity is going to be equal to 2 pi r over t. Well, I've got enough information to find t because t is simply seconds per revolution. So it makes a half a revolution every second. So 1 second over 0.5, which is going to be 2 seconds, right? So I have the radius also. It's a 5-meter ride, 5-meter radius ride. So that means that velocity circular is going to be 2 times pi times 5 meters over 2 seconds. Those 2's cancel out. I get pi times 5. So I got I times 5, which is 15.7 meters per second. So then I would go ahead and find the acceleration by squaring that. So I've got over here, acceleration centripetal is going to be equal to 15.7 meters per second squared over the radius, which is 5 meters. So let's do this. I'm going to square the answer. And then we're going to divide that by 5. And that's 49.3 meters per second squared. So that's my acceleration. So I'm going to take that acceleration, put it in here. So it's going to be 100 kilograms times 49.3 meters per second squared. That means that that centripetal force, that normal force, is going to be times 100. Hit enter, and that's 4935 newtons. So that means that the coefficient of friction is going to be frictional force over normal force. I'm going to take that 4935 newtons, put that in here. So I've got 980 divided by the answer. Hit enter, that's 0.198 or 199. 0.199 is my coefficient of friction needed to keep this from sliding down the wall. I'm going to show you why the mass wasn't important. What I've got is frictional force, which is basically mg, right? Because that's how we figured this out. So this is mg. And I've got that normal force, which was ma. So when I figure this out, it really is mg over ma. Masses cancel out, so it's really no more than the ratio of the acceleration of gravity over the acceleration of this circular ride. But that's why mass wasn't important. I can make up my own mass if I wished for this.